This one has a couple more steps into it because we need to break down the angle vector. So two forces are applied to an object. One at north of east and one at south. What is the net force acting on the object? So, if we break, I'm just going to draw my vectors first. So, if I'm thinking of, here's north, east, south, west, this one needs to go kind of right in the middle here. So I have, and the magnitude of this is 10.1 newtons, and it's 36 degrees north of east. So I go from my east line, and my angle is north of it. So that's 36 degrees north of the east. Okay, so that's my first force that's acting here. Then I have another force that's going 4 newtons directly down. So this, I'm going to say is Y2 is equal to 4.0 newtons. Now, I'm going to actually put, since it's south, I'm going to translate the south word into the negative or positive. So what should Y2 be? As south. Negative, yeah. Okay, so I put a negative here. Because when we're adding our y's and our x's, we need to translate the direction into negative and positive. Okay, so now I can find here my x1 and my y1. Oh, and I should say over here too, what is my x2 of this vector? 0, yeah. So to find x1 and y1, you can use trigonometry to do that. So for our x1, it will be our cos of 36 is equal to x1 over 10.1 newtons. So x1 is equal to positive 8.17107 newtons. Our sine 36 degrees is equal to y1 over 10.1 newtons. So then our y1 is equal to positive 5.93663 newtons. So I like to go back to my initial diagram and just kind of write that in so that I make sure everything makes sense. So this is positive 8.17. That makes sense because it's going east, and that's a positive vector. And my y1 is positive 5.9, etc. newtons. So now to get an overall picture of what's happening with these, I need to add all of the x's together and all of the y's together and make a new triangle. Morgan gave them candies. Okay. So we have our x total. We could say this is step 2 as well. So our x total is x1 plus x2. When you add them together, you get positive 8.1707 because one of them, x2, is 0. So y total, we have to go positive 5.936, etc. newtons plus negative 4.0 newtons. So that's kind of where it really becomes important that you've included your negatives and your positives in your vector diagrams, because when you add it together, it needs to be negative. So then our y total is equal to only positive 1.93663 newtons. So then sometimes I just stop and think, okay, for a horizontal vector that's positive, what should that be? That's either east or west. So this is going to be east. Then for a vertical vector that is positive, that's going to be north. So when I'm drawing in my vectors, I kind of go back and think about that so that I draw my vectors properly. Again, they need to be from tip to tail. So in order to do that, now we have, this is step 3. We draw our north, so 1.93, etc. newtons. So this is our y total. And then we have our x total. Which was, what did I just say it was? 8.17? Yeah. 8.17 newtons. Okay. So it makes sense, I'm going up and over, and then I draw in, this is my F net. So your overall vector of your final triangle, that's your F net. And again, go from your starting place, and that's your theta. So to find the magnitude of F net, just like we did in last problem, you can go a squared plus b squared is equal to c squared. C is equal to the square root of 8.17 newtons squared plus 1.936. And don't, like I'm just rounding as I put the numbers on the board, but in your calculator, continue to use all of the numbers from your calculation. So don't just cut it off at 8.2 or 8.17, include all your data. So then your C is equal to 8.397 newtons. So that's our F net. Again, to find your angle, you can use your trig. So this is step 4. So your theta is equal to tan inverse of 8.17 divided by 1.93. So your theta then is 76.66, etc. degrees. And that is east of north. So you look at where the angle's starting, that's north, and it's gone 76 degrees east of that line. So east of north. Okay, so then we can put all of our data together and make sure we have significant digits. So we have 2 sig digs in this problem. So it's 8.4 newtons, comma, 77 degrees east of north.